Okay, so today we're going to be working on solving a system of equations by elimination. Previously, we learned how to solve using substitution. So obviously one of the things we're going to want to be paying attention to is how do we tell the difference? How do we know when we use one or when we use the other? If you remember, for substitution, the key is you're looking for a y equals or an x equals. So a lot of my students will tell me, how do you know it's elimination? They'll say, well, it doesn't have a y equals or an x equals. And that's a perfectly valid way to do it. Okay, so right off the bat, here's an example of a problem that you would use elimination. So take a second and see if you can notice how there are some differences between this and what we've done in the past for substitution. Hopefully you notice that there isn't a y equals or an x equals. And that's the key. Both of these are in standard form. Okay, remember standard form is when you have something of this form. Ax plus by equals c, and that's in standard form. If you notice, both of these fit that requirement of being in standard form. It's a system because there are two, and they're both in standard form. Okay, now the basis for elimination is still the same. We're going to start off with a blank point. You notice I put that on there, but whereas in substitution we're substituting like a substitute teacher, here we're completely trying to eliminate one of the variables. Okay, meaning we want to just cancel out either the x or cancel out the y's. It actually doesn't matter which one you do. However, the important thing here is to make it as easy as possible for yourself. Okay, in order to use elimination, we need to have opposites in each equation. What does that mean? It means if one of the equations has 4x, we need to have the other one with negative 4x. The reason is when we use elimination, we add them together and we're hoping to cancel out, to zero out something. Okay? So in this case, if you notice, we have a negative 2y and a positive 2y up there. Those are our pair of opposites. When a problem is set up like this, so nice and neat for you, it's very simple to do an elimination problem. Most people prefer elimination over substitution. So what do we do with those, right? So here we go. This is the problem we just looked at. 5x minus 2y equals 5, and 2x plus 2y equals 30. We identify our pair of opposites. As long as we have a pair of opposites, all we have to do is add our two equations together. So what that means is literally we put a plus sign and we add straight top to bottom. I don't know why my plus sign's a little low there. I'll fix it, but can't right now. So now I'm going to add top to bottom, and I do so one row at a time. So kind of imagine you have that row, and that row. We're going to add each of those individually. So we're going to start off with 5x plus 2x, which is 7x. Then we're going to add negative 2y and positive 2y, which make nothing. That's the point. We've eliminated, gotten rid of one of our variables. We still have our equal sign. Be very careful to keep that. And we're going to take 5 plus 30, which is 35. From there, we look at that as a simple one-step equation. Divide both sides by 7, and you get x equals 5. Just like in elimination, just like in substitution, we now have half of our answer. Okay, if you remember, what we did then is we now plug that back in. We substitute that back in. The same rules apply now as did for substitution. We want to plug it into whichever one of those looks easier. So take a second and think, which one of those would be easier to plug 5 in for x? Well, to me, it's the bottom one. My reasoning on that, I don't like to use the negatives. I don't want to deal with a negative 2y. It doesn't matter which one you plug into. It has to work in both because it's the answer for both of them. But I'm going to go ahead and plug it into the bottom one. So I'm going to replace my letter x with a 5, which gives me that right there. I need to subtract 10 from both sides and then divide by 2, and I get that y is 10. A lot of times what people look at in this method is they go, oh, that's so much easier. The first half of it's easy. The second half of it's a little bit more work. In substitution, the first half is more work, but the second half to plug in is very, very simple. You're done in like 2 steps. So there's no easier or harder way. You can use both, and I'll show you later how to kind of be able to use either one you want. But for right now, the easier one is up to you basically, but you got to know how to do both methods. You can't use elimination the way this problem is. You can use elimination, but you can't use substitution on this problem. You'd have to rearrange it. Okay, so we're going to go ahead and try one more together before you try some on your own. So right off the bat, first thing we want to do, identify our opposites. As you probably have noticed by now, we have a pair of opposites. They are our 5x and our negative 5x. As long as we have a pair of opposites, we're ready to do the problem. All we have to do is add our two equations together. The whole point of this is that one of our variables cancels. If that's not going to happen, and we're going to look at that in a second, we need to do some work to get that ready, because otherwise we're not eliminating anything. Okay, we're just ending up with a bunch of x's and a bunch of y's, and that doesn't do anything for us. We can't solve that. So when I add negative 5x and 5x, they cancel out. Negative 7y and positive 4y make negative 3y. Negative 8 plus 11 equals positive 3. And when we solve that, we get y equals negative 1. Make sure you put it in the right spot, and then we substitute back in. To me, the bottom one looks way easier. You can plug into the top one if you prefer. Just give it a try. Do whatever you want, but the idea is to make the problem simple for you. There's already enough work. You don't want to make it harder. So now I'm going to plug that negative 1 in for my y. Be very careful to make sure you plug into the correct variable. Last time we plugged into x. This time we're plugging into y. You plug into the wrong one, you're going to get the wrong answer. 5x minus 4 equals 11. Add 4 to both sides. And divide by 5. That gives me my 3. And that 3 goes right in for my x value. Once I have the whole answer, I'm good to go. Okay, so we're going to have you try one on your own now. So pause the program. Try to identify your opposites. Make sure you put that empty point there. Solve for one variable, plug it back in for the other one. Okay, so hopefully you had time to do that. We're going to go ahead and start the problem. Because we have 6y and negative 6y, problem's good to go. Put your plus sign, add up and down. 8x, y's cancel, 56. Okay, from here, I want to take 56 divided by 8, which is 7. Okay, so I know some of you aren't as great as your multiplication tables as you should be, so you want to have that handy. Probably don't want to use a calculator on something like this, but if you absolutely have to, as a resort to make sure you can solve the problem, that's okay. Make sure that goes into the correct spot. Now pick whichever one you thought was easier to solve. Doesn't matter if you pick top or bottom. I always have students who pick both. I like the top one because there's no negatives. Some of you might like the bottom one because it's smaller numbers. They're both fine. Solving, 6 times 7 is 42. Subtracting 42, I get a nice neat number, and y equals 2. My point now is 7, 2. A really good practice here is to go ahead and check your answer. The way you do that is you take that 7 and that 2 and you substitute it into the one you didn't check it in. So here I use the top one. I'm just going to plug it into the bottom one. 2 times 7 is 14. 6 times 2 is 12. Is 14 minus 12 2? Yep, my answer is correct. It doesn't take very long. You can even do it in your head, and it just double checks that all of this down here didn't have any mistakes. You don't want to waste all that time and energy when you could go back and fix something if you got it wrong. Okay, one more I want you to try on your own. So as you can see, you already have a pair of opposites. Pause the program. Go ahead and solve for x and y, and when you're done, hit play. Okay, so we're going to go ahead and add our problem, top to bottom. And we're able to do that because we have that negative 2y and that positive 2y. It's going to give me 3x. That part's going to cancel. Negative 14 plus 8 is negative 6. Solving, I'm going to get x equals negative 2. And I can plug into whichever one. They both don't look too neat. They're both a little messy. I chose the top one just because I didn't want to plug into a negative x, but either way would be fine. So 4 times negative 2 is negative 8. I'm going to add 8 to both sides. Be real careful when you get a lot of negatives involved, that you're careful and you take your time. And then you divide by negative 2 and you get y equals 3. Another great example of checking your answer. The opposite of negative 2 is positive 2. 2 times 3 is 6. Yep, that works. Okay, just a real quick way to check and make sure that your answer is correct. Now, What if there are no opposites though? Okay, so these are easy examples. So what if I gave you a problem where there wasn't any opposites? Right off the bat, you're going to notice there are no opposites. You probably see there's a minus sign and a plus sign, and that's a great clue as to what you probably should do. The idea here is if we don't have opposites, we need to make opposites. Okay, well, how do you just make an opposite? Are you saying can I just write a 4 in there? Because that would work, right? No, you can't do that. You can't just write a random 4 in there. The only thing you can do is you can multiply the top one or the bottom one by something to make it work. Well, here's the deal. There's a 1 in there. If I were to multiply that whole top equation by 4, then I would have a negative 4y, and then it would cancel out. So for elimination, one of the keys is that sometimes you can multiply either one or both of them by a whole number. But when you do that, you have to multiply the entire thing. So what I'm going to do is I'm going to multiply that entire top one by 4, every piece of it. So I'm going to go 4 times 2, which is 8, 4 times y, which is negative 4y, and 4 times 4, which is 16. Every single piece up here was multiplied by 4. It's very important to notice that I didn't skip any of those pieces. If you do, your answer will come out wrong. Now that I have a pair of opposites, I follow my normal steps that you just learned. Add top to bottom, add the opposites that cancel, and add those. You may end up with large numbers, I understand that. That's a part of it. And some of you may here not know, hey, 78 divided by 13 is 6. One of the keys I can give you on this is 6 times 3 is 18. So because 6 times 3 gives me an 8 in the ones digit, that gives me a clue that a 6 is probably involved. I don't know any other numbers that times 3 give me 8. So it's a very good clue to help you out as you do these problems. Now I can plug that 6 in. I pick whichever one looks easier to me. I could make an argument that either of them would be easy here. I choose to use the positive one in my example, but you definitely could do the top one. So I'm going to go 5 times 6, which is 30. Subtracting 30. Dividing by 4. Again, feel free to plug that into the top one. 2 times 6 is 12 minus 8. Yep, that's 4. A very quick thing to check your answer. And the most difficult kind of problem you will have in here is one where you can't easily make your pair of opposites. So looking at this one, you'll say, wait a second, I can't times 2 by anything to give me 3. I can't times 3 by anything to give me 2. I can't multiply 4 times something to give me 7, and 7 can't be multiplied by anything to equal 4. This is the hardest one because you have to multiply both the top and the bottom by something. My rule of thumb, use the smallest numbers possible. So what you notice here is, well, could I turn that 2 and that 3, each of them, into a 6? Okay, if I multiplied this times 3 and this one times 2, I would have a pair of opposites, 6x and negative 6x. So that's precisely what I'm going to do. I'm going to multiply both of the equations. Okay, careful to multiply every single piece. Okay, 2 times 3 is 6, 3 times 7 is 21, 3 times 41 is a big number, and the bottom, negative 3 times 2, 4 times 2, and 11 times 2. Remember, I still have my equations written up here if I need to look back at where I got the numbers from. If you're confused on any of this, pause it. Take a second, really think, how did he get each of those numbers? The key here is getting this pair of opposites. It's very important that I have those so I can proceed with the problem. Okay, now I'm going to go ahead and I'm going to add. That cancels out. 29y equals 145. Again, not too sure on that answer. You may need to go to a calculator for something like that, but the answer is, in fact, 5. Okay, now I'm going to plug into whichever one looks simpler. Probably guessed I used the top. Again, no negatives. 7 times 5 is 35. 2 times x is 6. So x equals 3. So even though it starts off as a really messy problem, the answer comes out to be something like 3, 5. Very, very straightforward, but there is a lot of steps to do. You got to be very careful. Take your time. If something doesn't seem right, go back and double check your steps. So I want you to try a couple of those very quickly here. The first one I want you to try is this one right here. So you're going to notice right off the bat, you do not have a pair of opposites. You need to multiply to create a pair of opposites. So pause the program, give it a try, Hit play when you're done. Okay, so this problem can be done two ways. You could either multiply the x by -3 or the y times 2 to make a -4. Either one works fine. I chose to multiply by -3 just to try it, just to make it different. Probably the easiest way is to multiply the y by 2, but it's good to see that either way can come up with the same answer. So when I do that, I get -3x plus 6y equals -24. Adding top to bottom, I get 10y equals -30. So y would have to equal -3. Plugging that in, I can now plug that -3 into whichever one I want. A lot of times people try to plug them into these. Don't do that. Those numbers are huge. Don't do that. That's too hard. Go back to your very original questions. The other thing is too, if you made any mistake on like this one, for example, or this one, and you plug into it, it's not going to help you. You want to be plugging into the ones at the top that gave you the very simple numbers, smallest numbers, before you changed anything. I went ahead and plugged into the top one. In this case, I was dealing with negatives pretty much no matter what, so I wanted small numbers. Okay, -2 times -3 equals 6. 8 minus 6 is 2. And that gets me my correct answer. As you might guess, I'm going to have you try one where you have to multiply both of them. So go ahead and pause the program. Hit play once you've figured it out, but remember, you're going to have to multiply the top and the bottom by something to make it cancel out. There are two ways to do it correctly. Pick whichever one's going to be the easiest for you to do. Okay, so in this case, what I chose to do was multiply the top one by 2 and the bottom one by 3. Why? Because then I'd get 6x and -6x, kind of like the example we did before. You also could have multiplied the top one by -4 and the bottom one by +5, or top one +4, bottom one -5. There's really a lot of ways to do it, just so that you can come up with an elimination that eliminates the y or the x. So following along there, as you can see, that's everything multiplied by 2, and that's everything on the bottom multiplied by 3. Now I'm simply going to add them together. And I get 22y equals 22. Much easier than that other one, right? 22 divided by 22 is 1. A lot of people put 0 for this for some reason, so be very careful. Y equals 1, and I can plug into whichever one. I chose the top because no negatives. So I get 3 times x plus 5 times 1 equals 2. That gives me 3x equals -3, so my answer is -1. Again, I can check my answer in the bottom one. That'd be +2 plus 4, which is 6. Always a good idea to do that quickly in your head, but that is your final answer on that one. Okay, so this is the last example. You're going to do some that quiz problems below this video. There's a link. Follow that. Go ahead and try those so I can get some feedback on how well you understand the process. There won't be too many hard ones, simpler ones, and then the last one might be a tough one. And then please fill out the form down below, put your name, and make sure you fill in all of the questions, even if the answer is, you understood everything. Be as specific as possible, because I look at these as a way to kind of help me help you the next time I see you. So go ahead and do that, and I'll see you next time.